I would like to thank the organizers and the esteemed speakers who are on the dais would share their experience, their views on AI and digital transformation. We have representation from public sector, private sector, services companies. It would be great to hear their views and learn from each other. I am Debasish Bera. I'll moderate the chair as the presentation goes on. I am with Accenture as a leading energy practice within strategy and consulting with over more than 23 years of experience. Have seen this industry grow from non-digital, non-AI to right now AI, Gen AI and agentic AI landscape. It's evolving. It's good to see that we are embracing these technologies, latest of the latest technologies. And we would like to hear from our panelists comprising from ONGC, Oil India, Reliance, Microsoft, Workwise, as well, Cognizant as service provider company. So it's a diverse mix of speakers that we have so that we get a roundabout view of their experience, their thoughts, their ideas, and their areas of work. So I'd like to introduce each of the speakers and call them up on the dais. They will share presentation. The duration is 15 minutes. There is no Q&A. We would have to wrap up the session by 11:30, and each of the presentations will be given their time limits. They will be given certain warnings as well, and they will have to wrap up the session in 15 minutes. Any discussion on the specific topic, you can catch up with those individual esteemed speakers post this session. Thank you. So I'd like to call upon, uh, should we start with Madam? First, you as a presentation. Okay. So Navjit, would you like to come and introduce yourself and start your presentation, please?
Good morning, everyone. I am Nabajit Baruah, Chief Manager, Reservoir. I am from ONGC, and I have been in ONGC. Currently I'm in the digital and transformation group of ONGC and looking into different projects for digitalization. So, in this work on agentic AI for reservoir management, so what we have done is we are trying to bring two ideas together. One is your agentic AI and reservoir management. So before going into the slides, I would like to touch briefly upon these two topics, the agentic AI and reservoir management. And regarding agentic AI, so let me start with a familiar reference point, ChatGPT. We all use ChatGPT, right? So most of us, we use ChatGPT to answer queries or generate text. And ChatGPT, it is very good in responding to single prompts, but it does not plan tasks. It does not break problems into steps, or it cannot manage any workflow. Whereas agentic AI, it is different. Agentic AI is all about giving AI a role, a goal, a tool, backstory, and it has the ability to carry out a sequence of actions. So instead of just getting a single response, what agentic AI does, it performs a process, and instead of just using a single model, it uses multiple agents that can work together and then can come to a conclusion. Now, regarding reservoir management, we know reservoir, it is an underground accumulation of oil and gas, and the reservoir management is all about how efficiently we are taking out the oil and gas from the reservoir and maximizing our recovery. Now, this involves huge amount of data. We have to go through large amount of data, structured, unstructured data, as well as different reports. So it involves, in practice, it is a multi-step reasoning process that is manually carried out by engineers. So we thought, can agentic AI can be utilized in reservoir management? So we thought, can an AI-based system that knows how to plan tasks and then coordinate actions, can that be used in reservoir management? So in this work, what we will show you is that how we have used agentic AI for information retrieval, for analysis, and then generating insights. So let's see the challenge first. So in reservoir management, when you are going to manage a reservoir, what is important is that you know completely about that reservoir. So now a reservoir, it can have many wells, hundreds of wells. Now again, each of these well, they can have many data sources like the formation evaluation reports, wherein the different formations that were encountered in that well, the petrophysical properties of that formations, all those things are written in there. Then we have the well cards, wherein the intervention history of that well, whatever workover jobs has been done historically, that is mentioned there. Then we have production history, how different, how that well has performed over history, what has been the production trend for a particular zone. So all this information we have to know for every well. Only then we can have an insight of that reservoir. Now what we have seen is that this process, it takes a lot of time, because every reservoir, it can have many wells, and you get the point, right? So then the second is the knowledge gaps. So suppose someone who has spent considerable amount of time within for studying a particular field or reservoir, he might have built that knowledge. With experience, he might have that history of the field, and based on that insight, he himself can take certain decisions. But what happens is that once that person is transferred to a new location, that whole information, that institutional memory, it goes with him. So someone who joins a new asset, or who has to look into the reservoir, he then again has to build, he has to go through this whole process again. He has to go to all well-wise reservoirs to build those insights. The third is the missed opportunities. Now because of the sheer amount of volume of data that we have, the amount of structured and unstructured data that you have to analyze before coming to any conclusion, sometimes there can be cases that we might miss some of the potential wells could be missed. Your time might be spent in analyzing a particular well, which may be less potential than a well that, if proper analysis was done, maybe we could have find more potential wells. So this is the challenge. Deriving value from vast, complex, and historically siloed data, it is a monumental task. And so how do we solve this? So the solution that we have seen is agentic AI Insight Engine. So what it does is, we are moving beyond simple information retrieval to information synthesis. So instead of sifting manually through all these reports, data, structured and unstructured data, what we are doing is we can go for automated reasoning, planning, and synthesis with the help of the AI agents that are connected to the respective, the relevant data sources of that reservoir. Now, this whole process is just like a group of experts that are sitting together, and they're analyzing a particular reservoir using different sort of data. We're just trying to mimic that, the current workflow that is followed in any E&P industry. And what we have seen is that through this process, this whole process, the manual, the number of hours that the time that we used to take to gain these insights from all the data, that can be reduced significantly from weeks to hours. So herein, the architecture behind is we have followed a 3-tier model. The tier 1 is the orchestration layer. Tier 2 is, it has a series of agents, and tier 3 is the synthesis layer. So what happens is, when a user asks a query, that query is decomposed into different, based on the query, that is the orchestration layer, it decides which agent it has to refer to. And then once that agent is routed, what it does is that agent, it goes to the respective data source, it retrieves the relevant information that is queried by the user. And then once all these agents, or the agents that were referred to by the router or the orchestrator, once those informations are got, there is another synthesizer agent. What it does is it makes a cohesive analysis. It makes a cohesive answer to all the information that was gathered by all these respective agents. So we'll see the workflow to understand more in details. So the agents that we talked about, so these are the main agents. One is the intent orchestrator. As you can see, it decomposes natural language queries. So if someone asks about the particular details about particular well, it tries to find out what are the exact details that it is asking. And then based on the query, it refers that query to different agents. So for example, it can have the formation evaluation agent, it can have a well card history agents. So likewise, there can be different agents, the production history agent. And then once the information is gathered from all these agents, the synthesizer, who is just acting like a senior engineer, who had got all this information from all these agents, and then it synthesizes all this information into a cohesive narrative, and which can subsequently be used by the reservoir engineer to act upon it. So this is the step-by-step workflow that we had followed. So the input can be simple, like what are the recommended zones or the perforation intervals in a particular well, and of those recommended zones, which zones have been perforated, what has been their production history, and what was the duration of that production. So those sort of query we can ask, and once the query is fed by the user, so that the orchestrator agent, what it does is it decomposes the query into different subtasks. And now, depending on the query, it can route that task to a particular agent. So we can, like for this query, if we are asking about recommended zones, it can, the first part will go to the AFR agent, who will go and, now this agent, they are expert, they are like subject matter experts. They have the knowledge about what is there in that formation evaluation report, what type of content they look into, and based on the query, which part of the document that needs to be retrieved. Similarly, it can go to well card agent, performance agent, and there can be likewise many agents. And once the information is fed from all these agents, there is a synthesizer who summarizes those observations from all these agents, and output is like it can give a consolidated response like this. These intervals X, Y, and Z were recommended, of which so and so were tested. The production history has been so and so, and then the user, the end user, like a reservoir engineer, he can then use his own engineering judgment what to do with that observation based on all the data that is linked with that particular well or a reservoir. So for implementation, this is how we have done. All these agents, they have a respective knowledge source. Like for AFR, we have so there are different workspaces that we have defined, and a particular workspace will have a particular kind of information. Like at AFR database, the formation evaluation reports, all the wells will be in a particular workspace. The well card history will be in a particular workspace, and likewise the production history, those will be in a different workspaces. And now to orchestrate all these agents, like so how do we do that? For that, we have used the Crew AI framework. So basically, Crew AI, it allows you to create different agents, and then using those agents, you can orchestrate. So multi-agent orchestration is enabled by this framework, and of course, the orchestrator as well as the synthesizer, they requires an LLM to process the information. And for that, what we have done is we have tried both open source as well as some frontier models. And of course, for frontier models, before using that, we had used for data sanitization was done so that this data is not leaked to any cloud. So this is just an example, a case study wherein for a particular well, the query was about which were the zones that were recommended in the FERs, and of those which were perforated or not. So as you can see, it found the recommended interval from the FER, and then it also found of those recommended zones which were the zones that were actually perforated. And so what it found was that 2 meters were perforated beyond the recommendation zone. Now it also gives a recommendation that okay, the 2 meters that were perforated that were not in the recommended, so you can go and analyze this. Of course, the 2 meter is also producing now, so you can go back and then analyze the results. So for a single well, so this is just an example. You can ask all types of queries related to that well. Depending on the data source that you have, you can ask queries and get an answer instantly from the model. This is just another implementation approach that we had used. It does the same thing. I mean, initially we had used that anything LLM application, but instead of that, we try to hard code everything here. The reason we did this, it gives you more freedom while, say, embedding the document and all. So in order to have more control and security, we had used this approach, but conceptually, it is the same thing. Just another approach of how we had used the multi-agent orchestration for the reservoir management. Now, in reservoir management, we cannot afford any sort of hallucination. Like, we know all these LLMs, they sometimes, when they do not find the required data, they tend to create some data that is not relevant, or they hallucinate basically. So how, and initially we did have this problem. Like, if we ask data about a particular well, what it does is, even if it finds the similar information from another well, it used to give, say, if I'm asking about the current power pressure interval of a particular well, so sometimes it used to give the power pressure interval of some other wells. So to counter all those errors, what we have done is we followed this verification protocol, wherein we have focused on the metadata filtering while retrieving document from the data sources. So through that, what happens is, even if the top 15 results are not from a particular well, it ensures that unless and until the data of that well is not found, it will search. So even it can go up to 100 results, and then it can retrieve the result of that particular well only. And then there is this anti-hallucination policy. It's simply like, if you're not able to find any data regarding that well, what it does is it replies as no relevant context available. So what we have done is, we had done this pilot project on a field of Western onshore basin, wherein around 30 wells. Now, each of these wells again had many data sources. So total data of 30 wells were used, and through this process, what we could see is that we could reduce the time from the weeks to hours. And through this, these are the main applications. These are the main applications of this work, that we could accelerate the well revival, we could identify seek wells, then we could optimize reservoir management, and also while reservoir simulation. Because in reservoir simulation, you have to do history maps. For that, you have to have an extensive understanding of the reservoir. For that part also, this can be a very useful tool. So this is how the roadmap that we have defined. We plan to scale it across assets. Then we can build more agents related to geology and geophysics. And then ultimately, all this information we can integrate with the simulation model so as to generate wall files, event files, and all. And then instead of just reactive, what we plan to do is we make it proactive so that it can itself identify opportunities. So yes, this has been a new standard that we have started in ONGC, and we, through multi-agent frameworks, it has been found to be effective. And this is easily scalable because it has a modular structure. And then, yes, it empowers engineers to focus on high-value decision-making rather than data collection. Thank you.
Thank you, Nabajit from ONGC. That was excellent in terms of getting a view in how agentic AI and next-gen AI capabilities are being used in reservoir management to ensure that we have productivity of existing and new wells get enhanced. I would like to invite Mr. Siddharth Kothari from Workwise. He's the founder and CEO, and he'll talk about AI-powered procurement. Thank you.
Good morning, everyone. My name is Siddharth Kothari. So unlike most of the presentations which you are going to see today, I'm going to talk about fairly simple yet invisible thing which makes a lot of projects possible in the first place. A lot of people might be talking about plants, systems, upstream like drilling and pipeline systems and whatnot. I'm going to talk about procurement. So coming to that, just before that, little bit about me. I'll try to keep this presentation very limited. I'll try to keep it within 10 minutes. And if there is questions, I would love to take them after this presentation. I'll be outside only. So little bit about me. I come from a family business into contracting and manufacturing. I've been seeing the space from past so many years, and I have a background in technology. I've done my BTech from IIT Bombay. So I thought, why not leverage technology to solve certain problems which makes CapEx projects easier. With that thought, jumped into it. So before talking about Workwise, which I'll talk about in maybe last two or 3 minutes, I would like to talk about the topic here, which is leveraging AI in the procurement world. So starting with that, in EPC projects, the most outcomes are determined by procurement, like cost, timeline, even risk, and yet procurement is being treated as back office activity, right? So I'll try to keep it a little bit engaging. Just show of hands, how many of you are anyway related to estimations, procurement, tendering, anything? Just show of hands. Okay, great. I have some audience. I think who will be able to pay more attention to it. So I'll come to the next slide. Yeah. So in projects, those of you who have raised your hand will know 60 to 70% cost goes into procurement. Yet, the procurement is that department which has the least visibility. Right? In the next slide, here I'm going to talk about what a procurement team deals with on a day-to-day basis. I'll just give you 10 seconds to register what we have here. They have 1,000-pager tenders. They have a lot of BOQs with 100 of line items. They have a lot of technical documents, which consist of technical data sheets, ITP, QAPs, drawings, a lot of other documents like approved make. And among all this, they have to synthesize information and do their activity. So basically, it is not a wrong process. It's basically a overloaded process, overloaded with lot of data. And in the era of AI, this work could be done very intelligently and could save a lot of time. Like what the speaker just before me talked about, the gist of that was saving time. What AI is doing for us in a very fundamental way, it is providing intelligence. The work which used to get a lot of time, maybe weeks or months, is being done in few days, few hours, right? It is important to understand where we should leverage it to have the maximum impact. So my topic for today is around procurement, and that's what I'm talking about. So it's basically a very lengthy, very overloaded process. If we talk about the cost, most cost overruns is not because of the extra manpower which happens on site. It is because of late bid submissions. It is because of weaker bid submissions. It is because of lack of clarity or delay in those procurement decisions. That's where your major cost comes into play. And those who are contractors, EPC players, they would know their margins get diminished because of delay or lack of, or I would say, not synthesizing or estimating procurement cost effectively. Next, so basically what ERPs and portals don't do, right? It is not a data problem. So procurement is not a data problem. It is document reasoning problem. If you can reason the document well, you'll be able to synthesize. And on top of it, if you could relate multiple documents together, reason it well, you'll be able to do your procurement in much simpler fashion. But that becomes difficult because we are right now doing it manually. Right? How it could be done? So what we didn't ask how we can replicate the current procurement flow. We didn't ask how we could automate the procurement flow. What we asked ourselves is how we could replicate an experienced sourcing engineer, how we could think like an experienced sourcing engineer. And with that thought process, we started training our AI models, make it like an experienced sourcing engineer. right? So what we did basically, now, so AI is a hype. A lot of people are say AI in like day-to-day activity. A lot of people are using ChatGPT also, but what exactly it is? What exactly it is? Basically, if you are able to reason the document, not just read the document, connect lot of documents together and reason them well, that becomes a superpower. And that's what AI gives us in this regard, at least, right? In next slide, I'll talk about how EPC tender is being handled in Workwise era. I'll talk about it. Please try to imagine it. I'll try my best to give you a better imagination how it is being tackled right now. And it's live. We have multiple clients who have validated, paying us. Imagine you have a tender, you upload it. Within 5 to 10 minutes, it gives you a very customized summary of whatever you need: commercial terms, scope, technical terms, your basic details, EMD securities, whatnot, to decide whether you want to participate it or not. What are your commercial queries? What are your technical queries? You could ask AI a lot of questions about those 1,000-page tender and get a clarity, right? Imagine it processing your technical documents, your technical data sheets, your drawings, ITPs, QAPs, and basically automate that processing. Whatever you want to do technical evaluation, it does that for you. Imagine you put in BOQ, you upload BOQ, and you get RFQ in return. Imagine you getting the cost comparison chart automatically generated, that too with apple to apple comparison intelligence, wherein you could compare two vendors' rates in apple to apple manner by adjusting for multiple factors which they might not have accounted for. So imagine this whole workflow right from the stage when your design drawing is done. So what I'm talking about EPC tenders, right? What is EPC? Engineering, procurement, and construction. So once your engineering is done, design drawing is done, right from that moment up till your procurement ends, when you've ordered your product and tracking, right? Imagine AI helping you at each stage. That's what we have built. So these are 3 different engines which we have built. First is tender processing engine, second is BOQ processing engine, and third is technical documents processing engine. And then we have stitched it together to make a workflow which becomes very easier and seamless to use. What it gives you? So speed is secondary. Speed is secondary here. What you get is control. Control is the most important thing which you get here. You are in control of your timeline, you are in control of your cost, you are in control, you know what are your risks, you have a lot of information first hand. Imagine this kind of clarity at day 1 and not day 100. When you start the project, you have this kind of clarity on day 1. Imagine that. That will be a huge boost. What you see right now here are the real numbers which we have seen in live EPC tenders, live EPC projects. These are not numbers for demo. And I'd be happy to run tenders or documents or BOQs if you have, just for the demo purpose on our stall. We are exhibiting in Hall 2, 2C01. Please visit. I'd be happy to do a live demonstration. I wanted to do it now, but actually we don't have internet over here. But what I thought was, in the beginning of my presentation, I put in a tender on the processing. By the end, in 10 minutes, we'll have processed output of it. But nevertheless, we could do it on our stall. So feel free to drop by. We are at hall number 2, 2C01. We'll be happy to process any of your tenders, BOQs, any technical documents, and show you how the output looks like. Right? With that, with this one important thing, AI will not going to replace procurement teams. A lot of people feel like, आप तो हमारी job खा जाओगे, क्या कर रहे हो ये? When we go to clients, a lot of procurement teams think like, यार ये तो हमारा job खत्म हो जाएगा. It's not like that. हमने शुरू में ये सोचा था when mobile computer games we felt like same thing कि यार ये digitize हो जाएंगी चीज़ें, बहुत सारे जो manual enter हैं उनकी नौकरी चली जाएगी. It's not like that. The team which is leveraging AI they will definitely replace those who are not using AI. That is going to happen. AI is not going to replace procurement teams. So this big fear of unemployment, that's not going to happen if we upskill ourselves. If we upskill ourselves to use those tools which are leveraging AI. And we could do that. We have been using, like Excel is also a tool. Similar, like what we have used is quite user friendly. So with that thought, again, I'll just invite you, if you are there, please come to our stall. If you want to scan this, this will show you our product in very brief. I have 3.5 minutes left. I'm Banya. This is my profit, what I have left. I would love to give you more understanding and explanation outside, since Q&A is not allowed here. But I hope it might have given you some idea of what AI could do for us in this whole CAPEX ecosystem. Even we are coming up, what we have done in procurement, right now, procurement thing is already live, clients are using. We are working similar fashion to solve engineering also. How you could create BOQ from drawing, how you could create 3D drawing from 2D drawing. So those will also be something areas which we are working on, and happy to partner with anyone. If you have those kind of use cases, please drop by and let us know your requirement in this overall EPC space, and we'd be happy to take it further. So with that, thank you. My name is Siddharth Kothari. It was lovely presenting what we have come up with here, and I leave you with some thoughts. Thanks for that. Thank you very much.
Thank you, Siddharth. Siddharth is from Workwise, and he also highlighted that they have a stall. In case there is interest, please visit their stall. We got to know details about AI being used in supply chain, and procurement is the most prominent function, whether it's an EPC domain or non-EPC domain. There is a huge utility of AI and streamlining procurement supply chain function. So with that, I would like to invite Lokendra Sharma from Cognizant, and he will speak about agentic AI based dynamic drilling rate of penetration estimation. Over to you, Lokesh.
So before I start, let me give you the brief on like how this project we started with. So I come from background of production engineering within the petroleum space, and I worked for almost 8 years before moving into consulting. So post that, while we tried reaching out to various clients. Now we felt within the last 1 year there's a nudge. It is not only the DEX will do give the business to us. It has to be we have to make the working models on that. So while working with the rigs, this was one of the like the ROP that we are getting from the well is optimized or not. So moving further, let me just start the like the initiation, like what is the problem statement. So we all understand like ROP is the most critical parameter while we carry out the drilling. We cannot make it, we cannot increase beyond the limit because it will lead to unintended events which will further complicate for us. And if we are not dealing with the sufficient speed, it is costing us. So we need an optimization, right? Now, historically, how the solution for this has been. So this is the actually draft PPT. This is not the final one. That's fine. Let me cover this from now. So the solutioning here is that we need a value which should be optimization there. Now the historical solution for this was like from the 1970s there was empirical correlations. Thereafter it is essentially in the 90s it came around with the data driven solutions. Now with the data driven solutions the problem was you give the input and there's an output, but what is actually happening, so the driller is not sure. So the adoption rate was very low, I would say till 2020 or 2021. Now, from thereafter, the adoption is increasing. So there's a huge opportunity here now. So how we approach this particular problem, the solutioning of this using agentic AI framework. So what we are now doing in our framework, we are segregating we are segregating the solution in two parts. First, the constraint part, we should be using empirical correlations because they are accurate, right? And the optimization part, we are going to use the latest AI frameworks, because then only the driller will have the confidence of knowing the constraint. So he or she will not going beyond the constraint. And this transparency is one of the key parameter. Because of that only the adoption of AI framework will be there moving further. I wanted to show two of the key papers on this regard. Like in the last December only, there's one huge paper came. I feel this is one of going to be path-breaking paper. How this agentic AI framework is being used by the ADNOC offshore. So similar to that. So this is again rough. So now. So this is now the solutioning. So this is also our like version 1. Now we are on version 5. So how we created this? We have now 5 agents. It is showing only 3 here with us. So first we have 3 constraint agents. Agent number 1 talks about what should be the mud weight range. The second agent, what should be the critical RPM. Third agent will talk about what should be the range of Q max and Q, basically mud flow rate. Once we have these 3 base with us, then we'll talk about what could be the prediction of ROP, ROP predictor agent. So for this we have used the correlation of BYM, which is the most efficient. And one of the key aspect of our solutioning is, let's say there's a correlation which we are using now, but there's a new correlation which comes up and which is better for a particular lithology or location, we can change that correlation. And that solutioning, like that particular part, will give the final outcome, better results. Sorry. So now the last part here is that we understand the data that we have used is synthetic data, but the understanding which I had of working almost 8 years, that I tried using it within our solutioning. After that, what we want to do further using this platform, we want to collaborate. We have to kind of come up with the solution showing the results to the industry, and we'll love to coordinate further. Thank you all. So all things happened because this was the draft PPT which I prepared around 20 days back. So the latest PPT is not there. So, but thank you.
Thank you, Lokendra. So he was supposed to talk about the demo and other details. In case you have interest around agentic AI in the drilling space, please speak to him offline post this presentation. I'd like to invite Azizul from Reliance, and he will talk about utility of agentic AI in the refinery operations. Over to you, Azizul.
Thank you for the introduction. So before beginning the presentation, let me give you a brief factual numbers that was stated by McKinsey and Company in the year 2022. They basically stated that whenever in a manufacturing industry, a particular predictive solution is used, the downtime of process equipment reduces drastically by up to 20 to 50%. Also, the efficiency of the overall process improves by increasing the throughput by up to 10 to 30%. Now, we might all accept that the fact, which is the reliability of any process equipment, whenever it suffers, the process efficiency goes down drastically. And because of this, there are consequences where the product that is produced goes off spec, and a lot of question remains in the minds of operation. So one such situation occurred in one of our FCC unit, which is the fluid catalytic cracking unit, where one of our product, which is the slurry oil, went continuously off spec at multiple instances. We were always revolved around one similar type of question, which was, could we have prevented these kinds of process disturbance beforehand? Or to be specific, were there any kind of process data patterns that actually revealed the upcoming process disturbances that would hinder the process efficiency? So this presentation is all about answering those questions and uncovering those hidden patterns by which we were able to improve the reliability of our process equipment as well as the quality of the product. So let me first take you through a brief introduction of what the product was. So as I said, the product was the slurry oil, which is a cracked product coming from the fluid catalytic cracking unit. Here, this particular product consists of some impurities like basic sediments and carbon ash from the catalyst fine and carryovers. Now, this particular impurity is needed to be filtered out in order to use it as a fuel oil in the downstream processes. So for that, we use the Gulftronic filtration system, which is capable of removing impurities of less than 5 micron. Now, the Gulftronic filter module looks particularly like this particular schematic in the slide, where we have an electrode present at the center, and across the electrode are small beads of glasses that act as dielectric medium. Now, this particular filtration occurs with the working principle of dielectrophoresis. So let me quickly take you through the filtration mechanism. Here on the left-hand side, we have a Gulftronic filter module, where in the center we have the electrode across which a voltage is applied, which is roughly around 10 to 30 kilovolt. And when this voltage is applied, an electrostatic field is generated. And because of this, the glass beads that were present, they get polarized and form a dipole moment, where some surface of the glass beads tend to be positively charged and the other part tends to be negatively charged. Now, when the filtration starts, the slurry oil enters the module from the top of the filter. It comes under the influence of electrostatic field, but since it is non-polar in nature, it goes out as is. But that is not the case for the impurities. As they are polar in nature, because of the influence of electrostatic field, they get charged, and these charged impurities get attracted towards the oppositely charged surface of the glass beads. And this is how the impurities get filtered out by sticking on the surface of the glass beads, and the slurry oil gets clarified. So when this particular charged impurities goes towards the surface of the glass beads, it tends to produce and induce electric current, which is the only process data that we capture through our sensors in the process historian and the DCS panel. Now, this particular filtration cycle takes place for a specific period of time, and basically after the filtration time ends, it is assumed that all the surface of the glass beads are totally covered with the impurities and are needed to be removed, and the surface is needed to be regenerated in order to go towards the next filtration cycle. So to achieve that, we use the raw oil as a backflush, which is actually the feed to the FCC reactor. And this raw oil sweeps away all the impurities that were present on the surface and goes to the FCC reactor where the impurities were actually originated. Now, the problem with this whole Gulftronic system is that we have around 24 Gulftronic filter modules operating in parallel. And whenever there is an off-spec product of slurry oil coming out, the operations tend to, become very stressed because they don't have any kind of process data except the electric current to actually find out which of the filter module is not working efficiently. And by the time they find out the culprit filter module, the damage is already done. So when we studied a little deeper into those filter modules that were not working efficiently, we found out that they had a similar kind of symptom, which was related to glass beads. So the glass beads have a particular shelf life after which they are needed to be replaced. Now, when the replacement is not done in the specific period of time, the symptoms like aging, contamination, and attrition of glass beads are being visible, which totally contributes to low efficient filtration cycles. Also, when the glass beads are not replaced, the raw oil itself becomes very less effective, and they are not able to remove the impurities because of permanent partial coating on the surface of the glass beads. Also, as I discussed earlier, we only have one process data, which is the single current readings on the DCS panel and process historian. These readings gave no visibility to filtration module health. That's why we found many instances where the quality metric, which is the basic sediments, went beyond the acceptable limit, as we can see in the first plot from 2018 onwards. If we look at the second plot, which is the filtration efficiency or de-ashing efficiency, it was steeply declining from March of 2024 to March of 2025, where at the end of the 2024, it was even below 50%. So we tried to change our perspective, and we tried to look beyond a single current reading, and we tried to look at the whole pattern that was formed by the electric current during the filtration cycle. And we fascinatingly found out that the patterns that were formed were strongly correlated with the filtration performance. The categories of filtration pattern are of three types, mainly based on the surface area that is available on the glass beads from the start to the end of the filtration. We have classified it as healthy pattern, degrading or transient patterns, and the unhealthy patterns. Now, the healthy patterns basically have a smooth and increasing nature of electric current, and this is basically because from the start to the end of the filtration, the surface area available for the glass bead is ample in the space of the filter module. If you see the second pattern, which is the degrading or a transient pattern, it is a little bit noisy and plateaued at the end of filtration cycle. This basically signifies that at the start, the surface area on the glass bead was ample, but till it reached the end of the filtration, all the surface area was saturated with the impurities. The third and the last one is the unhealthy or a bad pattern. Here, the shape of the pattern is also reverse or opposite to the first two, and this basically signifies a poor filtration efficiency, where the surface area available at the beginning itself is very low to negligible. So based on this information, we next tried to do something where a model or a machine could understand these particular patterns and try to give a quantitative metric by which it could tell us how the health of the filter module is changing in real time. So for that, we used customized algorithms to actually extract each of the filtration pattern in real time for all the 24 modules. These patterns were normalized, resampled, and then some of the information were extracted, which were current gradients, maximum current at the end of the cycle, the average current produced during the whole filtration cycle, and then some similarity algorithms like cosine similarity and Pearson correlation to actually find out the similarity between the actual current pattern and the healthy patterns that were manually identified for each and every filter module. Now, the next step was to aggregate all these important features into a model equation, which actually told us how the model was performing in real time. So we termed this particular model equation as module health deviation score. This equation is a trainable equation where we have some trainable parameters that can vary filter to filter, where this equation is trained on the healthy patterns that were identified manually. Now, this equation is quite similar to, the ReLU activation function, which is used widely in artificial neural networks. Here, the output of this particular equation is either 0 or any positive value, where a value of 0 signifies that the pattern that are produced are very much similar to healthy patterns. And if it deviates from 0, it signifies that there have been some process disturbances due to which the pattern has shifted from the healthy condition to unhealthy or degrading condition. Now, with some validations and real-time deployment, we tried to deploy this model in our internal smart manufacturing portal, where the live data were processed. And these are some of the screenshots of the portal where the model was deployed for every 24 modules. Here, each and every pattern were identified and categorized as healthy, unhealthy, or degrading pattern. And based on this, the operation continuously monitored it and took preventive actions whenever the score reached beyond 0.5, which actually indicated an unhealthy or bad pattern. The preventive actions were mainly checking of glass beads, replacement of the glass beads if required, checking of line temperature, and the choking of valves. So based on these preventive actions, we were able to see a drastic improvement in our process. The first plot that we can see here is the basic sediments and water that I had shown you earlier as well from the 2018 onwards. So we can clearly see and distinguish the difference when the model was not deployed and the deployment afterwards. Here we can see multiple incidents before the model deployment where the quality was not up to the mark and it was beyond the acceptable limits. But after the deployment of the model, and importantly, the operations taking preventive actions in quick time gave us almost negligible incidents where the product crossed the basic sediments acceptable limits. The same is the story for filtration efficiency or de-ashing efficiency. It was below 50% at one stage before the deployment of the model, but after that, it improved a lot and it reached around 70 to 75%, where we improved the efficiency by around 20 to 25%. And everything was achieved fully in-house at zero investment cost. So that is it. Thank you for giving me this opportunity to showcase our project. Thank you again.
For improving refinery FCCU operations. And the benefits that we saw is the last line is quite impressive with zero investment cost, all in-house development, in-house skills, capabilities. I'm sure this model will definitely be helpful for other companies and other industries as well. So thank you, Azizul. Now I invite Satabdi from Microsoft. She's the portfolio lead there, and she will talk about AI Sysmel Sentinel for oil and gas.
So I'll be speaking about Microsoft's generative AI capabilities for ENR today. And just one second. I'll be walking you through some of the top AI use cases that we have implemented with real life customers in Microsoft. So some of the top customers we have are Uniper, Galp, who are using Microsoft's AI to protect and strengthen critical infrastructure and ENR operations. We have helped Chevron and E.ON improve frontline worker productivity and safety with real-time insights. Energisa, Uretim, and Petronas have enhanced their energy and resources reliance with AI-powered decision-making and forecasting. Aker BP and South 32 are our customers for Microsoft Purviews. Most recently, Lloyd's Register and Idaho National Laboratories are using our Microsoft GenAI energy permitting solutions to streamline energy permitting for meeting growing energy demands. The first use case that I would like to walk you through is improvement of frontline worker productivity and safety with real-time insights. Leveraging AI to produce real-time actionable insights is crucial for safety and decision-making. AI can analyze vast amounts of data and deliver timely information that helps workers make informed decisions on the spot. This can lead to quicker response and to potentially avoid hazards, better resource management, and overall safer working conditions. Utilizing AI increases productivity and reduces downtime, accelerates efficiency across multiple energy roles, enhances work safety, and with real-time secure insights. It also helps automate tasks. With Chevron, which adopted Microsoft Azure IoT operations enabled by Azure Arc to manage and analyze data locally at remote facilities, its real-time insights ensured that worker safety was ensured while lowering operational costs, empowering staff to focus on complex, high-value tasks. Eon UK adopted Dynamics 365 to enhance IT efficiency and customer satisfaction. The solutions included sales, customer service, field service, asset management, and integrates with third-party applications to support and automate processes. Using Dynamics 365, they have eliminated 20 minutes per site process for managing property handoff and have seen increased productivity with 20% reduction in job durations. I'll be sharing this presentation with all of you. There are a few clips and images with real customer examples that you can go through. Another use case is enhancing energy and resources resilience with AI-powered decision-making and forecasting. By using AI to enhance E&R, improve real-time performance monitoring, and it helps in assessing and managing risks associated with equipment maintenance, weather, and wildfires. Our customers that have benefited from this are Energisa and Petronas. Energisa Üretim is a Turkish energy company transitioned to cloud-native ecosystem with Microsoft Azure a few years ago. And since then, it has built a remote operation center that oversees 20 hydrocarbon, wind, and solar power plants 24/7. Through advanced AI analytics, Energisa can monitor real-time performance, forecast production levels, and predict maintenance requirements. It also fortified operations with a specialized security operations processing 3.3 million security events daily. In 2020, Petronas built Enterprise Data Hub, EDH, a unified enterprise platform service by Microsoft Azure at the core. This platform has empowered employees with accelerated knowledge extraction and enterprise analytics at scale, supporting Petronas' ambition of becoming a data-driven organization along with Microsoft. Another use case that is to accelerate exploration with generated insights and intelligent search. It helps improve knowledge sharing, accelerate time to market, increase efficiency and satisfaction with AI-assisted reporting and documentation. It frees up valuable resources previously spent on manual tasks, empowering employees to focus on higher value tasks. It helps with proactive secure data management as well, enables faster intelligent decision making and reduces risks. The customers that have benefited from this work stream are Aker BP and South 32. Aker BP chose to work with Microsoft to reach the full potential of its data to meet its operational excellence goals, facilitate informed decision-making, experience transformative impact in harnessing the power of Azure data management for energy to analyze vast amount of data. South 32 links people, tech, trust in data with Microsoft Purview Unified Catalog. It adopted Purview to unify data governance, improve discoverability, and make trusted data available across teams, supporting critical workflows. So the next use case is one that I personally worked on. It was used to streamline energy permitting with AI-powered automation to help grow energy demands. So the primary problem statement in hand was that the approvals for permitting used to take lots of time, used to take years and years, eons of time. So we came up with this solution to help accelerate permitting for clean energy conversion projects. Some of the customers we worked with are Lloyd and Idaho National Laboratories. Along with this, we also worked with Allo Atomics, Terra Praxis, Constellations, and majority of the energy consortium companies in US. For Lloyd's Register, it's a nuclear company. It used AI to accelerate nuclear technology adoption in maritime. And Idaho streamlined nuclear permitting and licensing with Azure AI-powered solutions built on Microsoft services. For this, we used Azure AI Foundry using the latest ChatGPT 5.2. And it has helped reduce the approval time by 82% and the labor cost by 70%. And currently, this solution is available to all the customers for free license. So anybody can apply for it. All you have to do is reach out to genai@microsoft.com. Another very generic use case that we have that most of us overlook, because in ENR, we understand that this industry is very equipment heavy as well as labor intensive. You cannot reduce costs and compromise in equipment that may lead to HSE incidents or any security threats. So where can you optimize costs? Perhaps using Agent AI, you can optimize costs in your daily operations, processes, administration, which Microsoft has enabled not just for ENR customers, but across the globe. Some of our customers that benefited from this are Uniper and Galp. Here is a detailed use case of how we made it happen for Uniper. Please do go through it. I'll be sharing the PPT. And some of the other energy customers that we've worked with are listed here. Ma'aden, EGA, and ExxonMobil. Thank you. That was all from my end. And my LinkedIn QR is there on the screen. If anybody wants to connect with me or get to know about more Microsoft offerings, or if you want to connect with any other teams for any other Microsoft products, please do reach out to me. I'm available. I'll be sitting here for the rest of the session and 1 hour after that in the speaker lounge. So thank you so much.
Thank you, Shatabdi. She spoke about a lot of use cases being implemented at oil and gas companies, energy companies. Being a hyperscaler, Microsoft is one of the major company who has plethora of use case implemented. So it's good to get a high level view of those use cases. Anyone wants to know more on those depth and those details of those use cases implemented at customers, they can contact Shatabdi and get to know more on those details. So thank you, Shatabdi. I like to invite Mr. Akash from Oil India to speak about their agentic AI revolution for their reservoir management.
I'm Akash from Oil India. A brief introduction about me. I'm working as a shift process engineer in a crude oil dehydration plant. My main job is to dehydrate the crude, the wet crude that is coming in my plant, and to dispatch dry crude to the refineries. Okay, I would like to tell you why I did this project. This is a solo initiative by me. What I felt that in my plant, whenever there is a breakdown, I felt that it takes a lot of time to bring it to its required, to bring the equipment to its required operation parameters. And what I felt that we need to call an OEM engineer, and he even diagnosing the issue takes a lot of time. What I thought, there must be some solution for that, so that we can reduce the downtime of any equipment. Here, for an example, I have taken plate and flame heat exchanger. Okay, let me tell you about what is a plate and frame heat exchanger. In this, there is a wet crude oil inlet and there is dry crude oil inlet. In this, there are plates across which heat transfer takes place. It is a very critical part of our plant. What happens? Uh, I will call plate and frame heat exchangers as PFHES. Plate and frame heat exchangers (PFHES) experience frequent mechanical and operational damage due to thermal and mechanical load. There are typically different types of failure that can occur in a plate and frame heat exchanger, such as gasket leaks, fouling, corrosion, deformation, and most of the failures, most of the maintenance actions that are initiated by us, they are done when there is any visible failure symptoms. So this approach is reactive in nature. So this what is does, it takes a lot of time to make the plate and frame heat exchanger operationalize. Oh, why the conventional maintenance was short? Because maintenance that gets triggered only after some visible abnormal conditions are observed, and they are mostly static in nature. Because they being static in nature, they do not account the real-time scenarios, what is happening in the plant, and they do not account what is the process parameter of the given equipment, and they do not know what is the upstream and downstream equipments that are connected to that heat exchanger. So what happens? My solution, sir. Can we wait for a few minutes?
Can I ask just because I wanted to show the result now? Will not take much time, just 2-3 minutes in the last after this.
You are?
Like in the last, I will just show my PPT, the latest PPT, just covering the main part of the result part.
Okay, let's see if 11:30 अगर 2-3 मिनट मिलता है तो, बट ऐसे ऐसे
But let me ask the PPT first.
yeah.
Okay, I am
So
telling
let's
you
continue.
why conventional maintenance was short. Because most of the maintenance is triggered when there is some abnormality absorbed in the equipment, and they are mostly generic in nature. What the SOPs that tell us, they are generic in nature. They do not account any real-time scenarios, such as what is the process parameters, that is what is the process parameters, and they do not take in account upstream and downstream equipments of the plate and frame heat exchanger. And what happens if there is some failure? There is lot of cognitive load that most of the heavy lifting is to be done by the engineer, and so sometimes it takes a lot of time for an engineer to find out the solution and make the plate and frame heat exchanger operationalize. Here what I present is a agentic rack based maintenance framework. Most of my colleagues have told you what is an agentic rack, so I don't think I need to tell you what is the basics of it. What I have implemented, I will tell you. Here, what my LLM does, here what my agentic rack does, that it gets a preliminary report, which includes some process parameters and what were the some observations made by the operator. And after processing that, it gives us 3 reports, such as safety and compliance report, system assessment report, and what are the maintenance activities that are to be carried out. For training as a knowledge base, I have feed a few of the documents, few of the data set, such as I have provided API 662, OSD standard 134, and the main purpose of the API 662 and OSD standard 134 is to ensure that whatever the recommendation that is coming from the AI, it is compliant. It is compliant as per the industry standards, And in OEM PFHE manuals, it tells about what are the mechanical constraints and the thermal constraints in which we need to operate the equipment so that whatever the results that AI is generating, it remains within that limit. And I have also embedded real failure cases based on the past history. Sometimes what I felt that there was no data related to some of the issues, so I created synthetic data for that. It was validated using physics plus standard screening was done for feeding that data. And I have also fed a PNID topology. It tells my AI what are the upstream and downstream equipments of that particular plate and frame heat exchanger is there. Okay, I have multiple agents. In my agentic RAGs architecture. Here I have mentioned 8 agents, the main 8 agents. Most of the agents are using the same AI stack, but how I have differentiated their roles, I will tell you. First of all, I have prompt engineered as per the requirements of that agent, and then I have given only access to only few of the RAG tools, means few of the RAG documents, and I have also made few of the tools which is accessible by only that particular agent only. Here the main role of the plant and context agent, I am telling you, it has to build operating context without diagnosis faults or suggesting actions. It receives unit status, load and ambient context. It always executes first and cannot be bypassed. The output it produces is unit state, operating phase and risk bias. And the second agent is plant and frame heat exchanger fundamental agent. It interprets plant and frame heat exchanger design, intent and operating envelopes. The RAG document that it can retrieve is only OEM manuals and design data sheets. The tools that are available the tools that are available to it is only those which can help it to calculate some plant and plate and frame heat exchanger type calculations only. The report it produces is the report it produces is operational reports, means it tells us what the parameters it should operate within. There is an internal mechanics agent. It focuses exclusively on internal plate, pack and frame health. It receives documents such as failure records and relevant OEM clauses. And for input, it receives differential pressure, patterns and mechanical history. And the output it produces is mechanical health, suspected issue and confidence. There is a leakage specialist agent. It analyzes gasket bypass, cracks and cross contamination. It has access to gasket history, startup leak cases and shift logs. And the input it receives is census and the observations made by the operator. And the output it produces is severity and confidence related to leakage. And there is a fouling specialist agent, and this detects fouling progression using thermal and hydraulic trends. This receives, and the RAG document that it is accessible is DP trends only. The output it produces is fouling stage, trend and risk level associated with the associated. And the last one I would like to tell you is the compliance and safety agent. It acts as a safety gatekeeper. It is limited to SOPs, LOTO rules and OEM safety clauses. It produces output such as safety clearance, status and violations. Here I have used multi-model RAG because I had images. For that, what I did, first I had summarized an image and produced a JSON schema for that image so that my LLM model can easily understand what it is going to get. And then the text that I got, I divided it into multiple chunks and then I embedded it into the vector database. Here I have used BGE embeddings. It is an open source embedding, and I have used open source model, LLM model, that is Llama 4.0. Here is a brief architecture of my agentic AI. What it receives after retrieving from the retrieving from the vector database, the query goes to the Llama, the LLM model, and then I have a master agent which orchestrates, which coordinates among all the agents, and all the agents communicate via A2A protocol, and there are multiple agents, which there are some specialist agents such as leakage specialist agent, surge and damage agent, and fouling agent, and some agents such as PFA, plate and frame heat exchanger fundamentals, and plant context. They were made using LangGraph, and others were made using Creo AI. Here I would like to tell you about some of the system components. First of all is multimodal reasoning engine. For that I have used Llama 4.0 Vision. For multi-agent orchestration framework, I have used LangGraph and Creo AI. I have made various tools for an agent. They were communicating with the agent using MCP protocol, and the agents were communicating within themselves using inter-agent communication protocols named A2A, agent-to-agent protocol. And I have used AWS Bedrock for deploying my project. Here I am going to tell you one of the case study. Here I have prepared one of the results. Here there was an leakage, internal leakage that was observed. Here what were the operating parameters that was fed by the operator. The wet crude inlet temperature was 30.6 degrees Celsius. Wet crude outlet temperature was 46.3 degrees Celsius. And dry crude oil inlet was 88.2 degrees Celsius. What it was observed that the total particles of hydrocarbons were less than 2 ppm, and some infrared survey was also made to know what is the internal condition of the heat exchanger. Initial condition of the equipment before restarting was there were no external leaks in the prior month, and there was and the last pack compression check was made 12 months ago. And the abnormal behavior that was observed was that there was gradual decline in the pressure over 8 hours from 0.5 KSC to 0.38 KSC. The few of the immediate actions that was suggested by the LLM agentic RAG was it prepared control shutdown, and it told us to line up for the die and hydrostatic press test. It scheduled partition gasket replacement and A-dimension restoration to OEM specification. Sir, shall I continue? Okay. And this was the maintenance activities that was suggested by the agentic RAG. First of all, it told us that to first isolate the equipment and then pre-repair diagnostics. Sir, only 2 minutes. Sir, actually my time wasted due to that drum. Okay. Sir. Okay. It also tells us what are the equipments that are required to carry out the operations. And in this, I have also made provision that if LLM is not telling something right or something is missing from the LLM part, we can also write that in issues encountered and their resolution column. This was the safety and compliance report that was generated by my agentic RAG. And this was the system assessment once the maintenance was done, how we can verify whether the plate and frame heat exchanger is working fine or not. For that, this system assessment report was generated. And these are the results of my agentic AI. Uh, Thank you for your time and attention.
So it's very hard to stop so many passionate, esteemed speakers. So, but we have to stop. But in last 1.5 hours, we could get a sense of the spread and the depth of the work our industry, our consultants are trying to do. I could easily recollect and assess some of those use cases while being at Accenture. So we do similar work with some of the clients and being privy to some of those experiences. But having said so, sitting in front of those some of my esteemed clients as well on the same dais and hearing them their actual stories, it's worth mentioning, and it's praiseworthy. So thank you, gentlemen, and thank you, my esteemed speakers, to share their views and experience. With this, we conclude the first session of day 2 in the supply chain and logistics stage. Thank you.